Hello, here is 7-2 talking about similar polygons. What you're going to see here is that this is related to congruent polygons, which we've seen before, but in this case they just have to be similar, meaning they will have the same overall shape but not necessarily the same size. You can see an example of that in the diagram right here, where it looks like that is a trapezoid. So trapezoid ABCD is similar to trapezoid GHIJ. So when we have similar polygons, what's going to happen is all of the corresponding angles are going to be congruent. And you can see that over here on the right side of the screen, where all four angles must be congruent to the corresponding angle. And then also the side lengths are going to have to be proportional to the corresponding side lengths. So you see that with AB, there's AB highlighted, is to GH, which is equal to BC is to HI. And we can just continue with that proportion. It looks a little bit awkward mathematically to see three equal signs, and that's what's called here with an extended proportion. Now to look at a sample problem. This is sample problem 1. We are given that triangle MNP is similar to triangle SRT. And there's that symbol right there. That symbol stands for similar. And just based on those two triangles that were given, I want you to ignore the picture in the bottom right corner because we don't necessarily need it. Just based on the order of the vertices of the triangles that were given, we can automatically see that angle M, since it's the first angle given, is going to be congruent to angle S, whereas angle N is going to be congruent to angle R because they are the middle two vertices. And then we can also say angle P is congruent to angle T. Then for B, what is the extended proportion for the ratios of corresponding sides? We need to sort of picture these two triangles rotating around so that they are being oriented in the same direction. Let me redraw one of these triangles so that now they'll look a little bit more similar. Hopefully that now everybody can see that. So this would be vertex P, this would be vertex M, and then N would be this vertex up here. So now we'll see that PN over, that's our long side there, so that must be proportional to our other long side, which is TR. So that's equal to, now let's pick that short side on the bottom, PM, which is to TS, which is equal to our third side, MN, is to RS. And once again, those pictures are not necessary. You could just focus on the order of the vertices in the given problem to answer that question. Here is our next problem, problem 2. Now we're going to determine whether these two, in this case quadrilaterals for letter A, if those two quadrilaterals are in fact similar. So if we first focus on angles, you'll see that the four angles do in fact correspond to a congruent angle on the other one. I can say angle M is congruent to angle W. I can say angle K is congruent to angle U. Angle L is congruent to angle V. And then also the last one would be angle J is congruent to angle T. So now we need to see if we can set up an extended proportion for the side length. So let me start at the top there. 12 is to 6. You'll notice that that's just a half, so that means it's going to have to be a half for each of the other corresponding proportions. Well, I should say 6 is half of 12. Overall, that's the same as 2 is to 1. So now if I focus on JM and TW, those side lengths are 6 is to 6. Notice that that is a false statement. So our extended proportion is false, so therefore these two quadrilaterals are not similar. Now to look at example B, triangle ABC and triangle EFD. So if we focus on the angles again first, it looks like angle C will be congruent to angle F. Angle A will be congruent to angle D. And then angle B would be congruent to angle E. So far so good. We've shown that all three corresponding sets of angles are congruent to each other. So now we'll set up the extended proportion. Let me focus first on what's opposite C here. And the side opposite is 12. So 12 is to 15 as 16, there's 16, is to 20, is to, or 8 is to, the last one would be 10. So now these are fractions. We can reduce these. 12 is to 15. 3 goes into both of them, so that simplifies to 4/5. And then if you look at the other fractions, you'll see that they all also simplify to 4/5. So therefore, B, we would say that yes, they are similar.